asked questions about a piecewise function. And whenever I see piecewise function, I want to see a graph. And so, first of all, I put these in the right order. So from the left to right, the -3 to -1, this piece is actually first, because it starts at -3 and quits at -1. Then the next piece, the one on the top here, it starts where this one stops and finishes when x is 1. And then this one in the middle is actually the last one because it starts at 1 and it finishes at 2. So to see these, here we're going to first graph the one from -3 to -1. And that one is, here's the first function. Oh my goodness, it's huge. Okay, so here's the 2 minus x just from -3 here, from -3 over to -1. So then the next thing I'm going to graph, I'm going to keep this here, and I'm going to graph 3 times the square root of x. And that's going to be the first 2 functions. And we'll have to make it a lot smaller so we can manage it. And so that's this. Notice we have the red one from the original that's from -3 to -1. And then this is 3 times the absolute value of x from -1 to 1. Then we'll load in all 3 of them together. And you'll see that there's a disconnect when you have all 3. You'll notice that you had to pick up your pencil. So there's a discontinuity right here at 1. Because you had to start back down here at 0 and come over to here. So to answer the questions, the domain, well, this, do we want interval notation? It doesn't say, so I'll do both. So the domain is x, I don't know how specific your teacher is, a member of the reals, such that -3 is the smallest, but it can equal -3, and 2 is the largest. In interval notation, this would be -3 to +2. Now the range is all the y values, and you'll see, excuse me, you'll see that the smallest y value is right here where y is 0. So this is y. They're all members of the real numbers, such that the smallest y is 0. And when x equals, it would actually be an equal here and a closed circle here. So this is a strictly less than because 1 isn't included in this piece, right? It's strictly greater than 1. So y is not 0, but very close. And then this is y. And the biggest y value that you ever get, you get everything from 0 to 1 here and here and here. And then you get from 2 to 3 from here and here. But then this one gets you from 3 all the way up to 5. And it does, if you plug in -3 here, -3 is included. So -5 is a less than or +5 is a less than or equal to. If you were going to do that in interval notation, the 0 would have a curve and the 5 would have a square bracket. Okay, so then local maximums. Well, the absolute maximum value, let's start there. The absolute max is the highest, is the point with the highest y value. And so the absolute max is 5. It didn't ask for an ordered pair. The value of the maximum is 5. It's located, if you need the location point, it's located at -3, 5. Or you would say it's located at -3 and its value is 5. We should probably say that. If you wanted the point of coordinates, it would be -3, 5. There we go. So then all local maximums. So if it's a local maximum, it's the highest point from the left or the right in its neighborhood. And so this one doesn't have anything coming from the left. So it's an absolute max, but it's not a local max. And then this is a local min, but they didn't ask for local mins. This one from the left is the highest in its neighborhood. And from the right, it's the highest in its neighborhood. So I think we can say that we have a local max at the coordinates are 1, 3. That puts us here on this middle one, the blue absolute value. I'm at the endpoint 1, and the maximum value is 3. And I think we have answered all the questions.